Hello guys, so I'm back for our next example under the topic of hydrostatic force on curved surface. So in this problem, and by the way this is from Engineering Fluid Mechanics, Mechanics 9th edition by Elgar, Williams, and Crow. Okay, so first is to determine the hydrostatic force acting on the radial gate if the gate is 40 feet long, normal to the page. So, kung ito yung ating gate, so parang ganyan lang. Okay, so this is 40 feet long. Okay, and then, so show the line of action of hydrostatic force acting on the gate. So, yung direction niya, kung anong angle from the horizontal. So, assuming ito yung direction. Okay, so we have to determine yung, so we will determine, okay, so yung angle from the horizontal. Okay, and does the force pass through point O? Dadaan daw ba dito? Okay, so by theory, so if we get the direction of the hydrostatic force in a let's say small differential area, let's say somewhere dito, no? So yung hydrostatic force, as we know, is always perpendicular on the surface. Okay, so at this point, okay, let's say ito yung direction ng force natin, and since this is perpendicular at this point, so alam natin na that will pass through point O. So if we get the direction of the hydrostatic force, so let's say differential hydrostatic force dito sa maliit na differential area. So perpendicular yung hydrostatic force dito. Okay, and if that is perpendicular dito sa circular gate, then this will pass through point O. So kahit saan tayo kumuha dyan, lahat ng mga components or mga differential hydrostatic force shall pass through point O. Then the resultant, of course, shall pass through point O. But i-prove pa rin natin, no, that the total hydrostatic force will pass through point O. So, brain lang muna natin to. Okay. So, in curved surface, so we solve the total hydrostatic force by components, no? So, first is, one is, of course, the horizontal, then the other one is the vertical component of hydrostatic force. So, simulan natin sa horizontal component. Okay. For the horizontal component, we just determine the hydrostatic force acting on the vertical projection nung gate. So, when we say vertical projection, ito. So, let's say somewhere here. So, yan yung vertical projection nung gate. Then, if we look from this side, papunta ro, nakatingin tayo doon. So, ang makikita natin dyan is a rectangular rectangular gate. So, rectangular yung makikita natin. Then, this is yung water surface. Okay. Then, sa gitna, this is yung center of gravity ng gate, ng area. Then, just below that, always below nung center of gravity or centroid nung area is yung ating center of pressure. So, yung hydrostatic force is acting on the center of pressure. But to get the hydrostatic force, the horizontal component, is we need to determine first the pressure. Okay, sa pressure at the center of gravity. Okay, so na-discuss na naman natin to dun sa hydrostatic force on plane surface. Okay, so ang formula natin again is that hydrostatic force on a plane surface is simply equal to unit weight ng liquid, then h bar, and then the area. So unit weight, and so this part, so this is actually yung pressure. Pressure multiplied by area is force. Okay, so let's solve for the horizontal component of the hydrostatic force. So unit weight, since English yung ating unit, so that is 62.4 pound force per cubic foot. Okay, multiplied by the by h bar. So h bar natin, this is 50. Okay, so yung height natin is 50, then h bar of course is 25. Okay, so multiplied by 25 feet. Okay, then area is this is 40 by 50. 40 feet by 50 feet. Okay, so tatlong feet, so cubic foot divided by cubic foot, so we can cancel those units. So may iwan na lang is yung pound force. So of course yun din yung in-expect natin unit since we're looking for hydrostatic force. Okay, so let's solve this. So 62.4 times 25 times 40 times 50. Okay, so we have 3,120,000 pound force. Okay, so that is just the horizontal component. Okay, so next is para dun sa vertical component naman. As we have discussed dun sa previous lectures natin, so the vertical component of the hydrostatic force is equal to the weight of the liquid. It can be directly above or hindi natin sabihin indirectly above, okay, nung surface natin. Okay, so dito sa gate natin meron tayong pwede natin itong hatiin into two parts, no? So if we get the horizontal, so let's say somewhere dito. Okay, so from this point going up, so yung liquid is directly above nung gate. Okay, so lagyan natin ng line. Okay. Okay, so ito yung volume of water directly above itong upper part ng gate. Okay, so magkakaroon tayo ng let's call this FV1, so vertical component number 1. Okay, so the weight of that volume of water, of course this is yung area, then meron pa tayong width na 40 feet. Okay, is equal to FV1. And then below, on the lower part of the gate, from this point, so mula dito, ito yung ating gate. So yung liquid kasi natin or yung water natin is below ng gate. So ang gagawin natin is ipaproject pa rin natin tong taas. Okay, so punta doon. So from this point, so kung ipaproject pa rin natin sa parang meron tayo imaginary volume of water above So, imaginary siya dahil wala naman tubig above nitong part na to. Pero, yun pa rin yung consider natin, no? Okay, so that is just an imaginary volume of water. Okay. So the weight of this volume of water will be equal to, pero since this is imaginary volume lang, no? Ang pressure natin talaga nanggagaling dito sa ilalim dahil nasa ilalim yung water natin. Then the second vertical component, so let's say FV2, okay? So is equal to the volume of this imaginary water. Okay? So, paano natin kinukuha yung weight? Which is, again, equal dito sa vertical component ng hydrostatic force. Okay? So, diba, weight, given yung unit weight, which is, ang unit ng unit weight is force. In this case is pound force per cubic foot. So, kailangan natin makancel yung cubic foot. So, we have to multiply this by volume. Okay? So, volume is in this case is cubic foot. So, makakancel to. So, makakuha natin yung force. Again, this is equal to the vertical component of the hydrostatic force. So, paano natin makakuha yung volume? Okay? So, volume so, meron kasi tayong dalawang, let's say, FV2 minus FV1. Okay. So, ang na-expect kasi nating direction ng hydrostatic force. So, since, sabi nga natin, yung, dito lang, no, sa horizontal component muna, dito sa vertical projection ng area natin. So, yung center of pressure is below ng center of gravity. So, if this is yung center of gravity, ng gate, okay, or yung area, centroid ng area, then just below that is yung center of pressure. So, yung horizontal component is acting somewhere dito. Okay? FH. Then, sabi nga natin, as we expect, yung total hydrostatic force shall pass through point O. So, in-expect natin ito na pataas. Then, the vertical component, FV. So, let's say, dito yung magiging center ng hydrostatic force. Okay, so, yung FV is going up. Okay, so, if we determine if we get the summation of vertical forces, so we can easily determine that so yung FV is equal to FV2 going up, then mababa siya nitong FV1. Okay, so vertical hydrostatic force is equal to the weight, which is equal to unit weight times volume. So, this is also unit weight times volume 1. Okay, so pwede naman natin i-factor out dyan. So, unit weight, so volume 2 minus volume 1. So, paano natin makuha yung volume? So, that is area times width. And this is area 2. Area 1 times width. So, same lang naman yung width natin. So, pwede natin din siyang i-factor out. Kayo wala ito, no? Width. Then, area 2 minus area 1. Consider natin itong blue part na area. Ito. Area 2. Then, itong green is area 1. Okay? So, kung titingnan natin, pataas, consider natin yung positive. Ito, pababa, consider natin negative. Okay. So, anong may iwang area? Or, if we multiply that by the width, the volume. So, may iwan tong portion na to, no? Ito. Okay. So, kapag inalis natin yung area 1 from area 2, so ito yung may iwan. Okay. So, that is the same concept na pagdating dun sa buoyancy, which will be our next topic after natin ma-discuss lahat nung nandito sa hydrostatic force on curved surface. Okay? So, kailangan pala natin makuha yung weight ng volume of water dito sa red shaded part. Okay? So, paano natin makuha yung area niyan? Okay, so pag may area, multiply by width, so we can get the volume, and multiply by unit weight, makukuha natin yung vertical component ng hydrostatic force. So, solve muna natin yung ating mga area. Okay, so bali mangyari, meron tayong area ng circular sector. Okay, so i-drawing ko na lang dito, no? Area ng sector is equal to, so madali lang naman tandaan yan. So kunin lang natin area ng circle kasi this is portion of a circle. So ang area ng circle is pi r squared. Okay, so r natin, radius is 50 feet. Pero ang kailangan nga lang natin is this portion of the circle. So anong portion yun ng circle? So that is, by the way, this is 60 degrees. So para natin nakuha yung 60 degrees, so kung meron tayong, kung kunin natin itong gitna. Okay. So meron tayong right triangle, so meron tayong height na 25, hypotenuse na 50. Okay. So opposite over hypotenuse is sine. So solving for the angle, so arcsine. Okay, so make sure na naka-degrees yung ating unit, ang ating angle. So sine opposite is 25 divided by hypotenuse 50. Okay, so that's 30 degrees itong kalahati. Then yung buong angle is 60 degrees. Okay, so anong portion lang ng circle to? Itong sector natin. So that is 60 out of 360 degrees. So 360 degrees kung circle. So 60 degrees lang yung meron tayo dito. Okay? So solve natin. Shift pi times 50 squared, r squared. Okay? Then times 60 over 360. Okay. So we have 130. So gagawin kong 6 significant figures siguro. Okay. So 1308996, so magiging 309.00. So this is in square foot. Okay. Then meron tayong area ng triangle. Okay. So area ng triangle is, if alam natin yung included angle, so that is 1/2 no? Diba? That's AB sine theta. Okay? AB, yung dalawang side. Okay? So, para sa silang 50. So, 50 feet squared. Then, sine of the included angle, 60. Okay, so 0.5, 1/2 is 50 squared sine 60. Okay, so we have 1082.53. So this is also in square feet. Okay. Then, pwede na natin makuha yung area ng itong part na to. Okay, so for the area of the circular segment, so that's the difference itong sector natin minus the triangle. So, na-solve na naman natin ito, no? So, we have 1309 square foot minus 1082.53. Okay? So, we will have, so, i-round off ko na dito. 09 minus 1082.53. So, we have 226.470 square feet. Okay. So, ngayon madali na nating masosolve yung hydrostatic force, vertical component ng hydrostatic force. So, that is equal to, again, the weight of this volume of liquid. So, unit weight, 62.4 pound force per cubic foot multiplied by yung area natin na 226.47 multiplied by width of 40 feet. So FV is 62.4 times 226.47 times 40. Okay. So we have 565,269.12 pound force. Okay. So we have the two components. So solve na natin yung hydrostatic force F. So which is equal to the square root of, okay, FH squared plus FV squared. So diretso ko na lang sa calculator na yung mga values. Okay, so that is the square root of 3120000. Okay, so squared plus 565,269.12 squared. Okay. So the total hydrostatic force F is 3,169,025.686 pound force. Okay. So that is the hydrostatic force acting on the gate. So for its line of action and to determine if that force will pass through point O, so we need to determine the location of the application of the horizontal and the vertical components. So for the horizontal components, since yung topmost part of the gate is on the liquid surface, shown dito sa picture. So if we will draw the pressure gradient, okay, so alam natin that the hydrostatic pressure on the liquid surface is 0, then it is linearly varying or linearly increasing. So habang lumalalim tayo, then nandito yung maximum pressure at the bottom. Okay, so we formed a triangular pressure diagram. So if meron tayong triangular, so the resultant will be acting, in this case, so 1/3 no height nung gate. So, if this is yung height natin. Okay? So, this is 2/3 nung height. So, if that is 2/3 nung height, paano natin, anong distance niya? So, ang gagawin kasi natin is para malaman natin yung direction ng hydrostatic force. So, first is we need to determine the angle muna. Okay? So, angle theta from the horizontal. So, madali lang to. We will solve this from the horizontal and vertical component of hydrostatic force. Okay? So, etong force na to, pwede rin natin siyang ilagay dito, di ba? Okay, so same lang yan. FV. So, meron tayong right triangle. So, we can solve for angle theta. So, theta is equal to, so since this is opposite the angle, this is adjacent. So, ito kasing hypotenuse natin, yung resultant. Okay, so that is tangent. Tangent is opposite over adjacent. So, that is arctangent nung FV over FH. Okay. Solve natin dito. Shift tan, arctangent of, so FV is 565, 269.12. Okay, then divided by 3120. Okay, so makuha natin is 10.2692 degrees. Okay, so that is from the horizontal. Okay, so to determine if that will pass through point O, so i-locate nga natin yung intersection nitong yung horizontal component. So, dadaan siya dyan. Then, yung vertical component, dadaan siya dito. So, from this point, meron tayong mapo-form na triangle. Okay. So, dito naman, we will solve for this angle. So, let's call this angle alpha. So, based on this height, kung naman yung distance nitong horizontal component from the center of the gate, pababa. And then, yung distance nitong FV, yung vertical component. Okay. So, from point O. So, yan yung para magiging base ng triangle. Then, ito yung height. So, pag nakuha natin dalawang distances na yun, so we can solve for this angle alpha. That should be equal to this angle. Okay? So, madali lang yung sa horizontal component. So, yung distance na yan, pwede natin gamitin ng formula. Okay? So, di ba meron tayong formula na ibaba ko lang muna to. Yan. So, di ba we have, if we call this yung distance E, itong part na to. So, let's call that distance E. So, yung formula nung distance na yon is equal to ICG, moment of inertia nung gate, over about its centroid over area y bar. Okay. So, y bar is, konting review lang, no? So, di ba ang y bar, kung meron tayong inclined surface, then ito yung ating liquid surface. So, yung y bar natin is yung distance from the centroid of the gate or the surface hanggang do sa may liquid surface along the plane. Okay? So, this is yung y bar. Then, ito naman yung h bar. Pero if yung surface na kino-consider natin is vertical, then same lang yung okay. So y bar is equal to h bar. Okay, so in this case yung y bar natin is yung h bar din. Okay. So how do we solve for distance E? So moment of inertia about the centroid. So madali lang matandaan to, no? BH cube over 12. Take note lang na kumukuha tayo ng moment of inertia, yung axis ng moment of inertia should be parallel doon sa liquid surface natin. So baka lang malito tayo, no? So laging parallel doon sa liquid surface. So about this axis tayo kumukuha ng moment of inertia. So this is yung B, then ito yung H. Okay? So B, yung width is 40. Yung H, yung height ng area is 50. So BH cube over 12. Okay? So yan yung moment of inertia about the center of gravity or about the centroid. Area natin is yung area ng rectangular vertical projection ng gate is 40 by 50 all in feet. Then y bar is okay, so from the centroid going up is 25. Double check lang. B h cube over 12. Area is 40 by 50. Y bar is 25. Okay, so simplify na lang natin. Alisin natin yung 40. Alisin natin yung isang 50. Magiging squared. Okay, so we have 50 squared divided by 12 times 25. Okay, so that's 25 over 3. Ito na lang. So that is in feet. So ano yung alternate solution? Okay, so based nga dito. Okay, pero yung distance kasi na kailangan natin is from the center of the gate pababa doon. Okay. So dito 1/3 h is equal to 50 over 3. Okay. Then eto naman mula dun sa center pababa dito. Okay, so mula dun sa center pababa is 25. So ito nga lang distance E yung kailangan natin. So E in this figure is equal to 25 minus 50 over 3. So double check lang natin. 25 minus 50 over 3. So same lang. 25 over 3 feet. Okay? So next, kailangan natin makuha yung distance or yung centroid. Okay. So of course, yung force, yung vertical component ng hydrostatic forces nakuha natin by solving for the weight of this volume, imaginary volume of water, no? Itong portion na to. Okay? Or, hindi lang volume, pwedeng cancel natin yung mga width. So, pwedeng area na lang pag-usapan natin. So, kailangan natin makuha yung centroid, yung distance ng centroid ng area, itong segment natin, yung centroid niya. Okay? So, let's say nandito, from point O. Okay? So, paano natin kukunin yun? Merong namang mga available na formulas to determine this distance. Okay? Mula dito sa may meron actually formula mula dito sa center ng circle papunta dun sa centroid nung segment. Although, medyo hindi siya ganun kadaling tandaan. Okay. So, doon na lang tayo sa mas, yung medyo mas, sabihin natin, simplified. So, meron din formula ng centroid nung sector. Ito, centroid nung sector, which is much simpler than yung centroid nito, location ng centroid nung segment. Okay, so para hindi na tayo masyadong marami tandaan. Okay, so gamitin natin yung formula ng center nung center nung sector. Okay. So bale ganito, no? Okay. So alam natin yung area, nung sector. So alam din natin yung area ng triangle and nung ating segment. Okay. So parang in determining the centroid of an area, let's say meron tayong irregular shape ng area. So pwede natin itong hatiin to, let's say area 1, area 2, or kung anumang shape meron tayo. Then let's say this is center to rectangular, so madali lang, gitna. So let's say that's x1. Then ito, centroid niya, papunta ron, that is x2. Okay, then kung hinahanap is yung centroid nitong buong area. So let's call that, so somewhere dito, let's call that x bar. Okay, para sa buong area. Then to solve for x bar, so if equation natin dito is yung total area multiplied by x bar, okay, is equal to area 1 x1 plus area 2 x2. Okay? So kung marami pa tayong areas, so continue lang yan, no? So plus area 3 x3 at so on. Okay. So gamitin natin itong formula na to. So yung buong area is yung area ng sector, okay, which is equal to by the way, so area, kunin muna natin yung mga distances. Okay. So yung centroid nung sector, yung distance ng centroid ng sector from point O, so meron tayong formula dyan. Okay. So let's call this x nung distance x nung sector. So that is equal to 2/3 of, okay, so r radius sine theta over theta. So yung angle theta should be in radians. Kasi hindi naman tayo pwedeng, ang hinahanap natin sagot dito is distance. So hindi ito pwedeng maging degrees. Okay. So dito sa formula na to, if this is yung sector, okay, so that is yung angle theta dyan is itong kalahati lang. Okay, so this is yung r. Okay, then ito yung distance x. Okay, so solve natin. So this is 2/3, radius is 50 sine of, so yung angle natin, so this is again 30 degrees, so okay, convert natin sa radians, so pi over 180 degrees, so 3 over 18 is 1/6. Okay, so sine of pi over 6, okay, over theta na pi over 6. Okay, so gawin muna natin tong Shift, setup, gawin nating naka-radians. Okay. So, 2 times 50 sine pi over 6 over 3 times pi over 6. Okay, so we have distance x ng sector is 31.83098. So gawin ko yung 6 significant figures. So 8310. So that's in feet. Okay. So sa triangle naman, okay, itong triangle natin. So if this is 50, so alam natin na this is 30 degrees. Okay. So this distance, itong base na to, so this is 50 cosine 30 degrees. Okay. Then centroid ng triangle is 1/3 from the base. So if consider natin itong base, then this is, so somewhere dito yung centroid. Okay. So this is 1/3 ng 50 cosine 30. Then yung kabilang side naman, ito. So that is 2/3 ng 50 cosine 30. Okay? So yun yung distance ng centroid ng triangle. Okay. So solve natin. So that is 2/3 ng 50 cosine 30 degrees. So lipat natin to ulit sa degrees. So we have 2/3 ng 50 cosine 30. So yung mga distances natin are from point O. Okay, mula doon sa center ng circle. Okay. So we have 28.8675. Okay. Then yung sa segment naman natin, so yun yung unknown. Okay? So since that is yung actual area natin na hinahanap, then let's call that x bar. Okay, so from this equation, so yung total area natin, or yung area of the sector is 1309. So this is square feet multiplied by its distance to centroid from point O, which is 31.8310 feet. So that will be equal to yung moment of areas of this segment and no ating no segment and of the triangle. So unahin ko yung triangle. So area of the triangle is 1082.53 square feet multiplied by its distance, distance ng centroid ng triangle from point O, 28.8675. Okay. So we expect na yung makuha nating sagot should be greater than, okay, so nandito kasi yung centroid ng area. So that should be greater than 50 cosine 30. So yung 50 cosine 30 is 43.3. So dapat mas mataas dyan. Okay? So plus yung area nung ating segment. So alam na natin yan, 226.47 multiplied by, so let's call that distance x bar. Okay, so we can solve for distance x bar. Okay, so we have 1309 multiplied by 31.8310. Okay, then pag tinranspose natin, that will be negative 1082.53 multiplied by 28.8675. Okay, then na-transpose natin doon. So we can now divide both sides by 226.47. So all over 226.47. Okay, so we have 45.996 9966 feet. Okay, so that is more than nung 50 cosine 30. Okay, so we know the distances, so we will solve for angle alpha again. So this distance from this point papunta doon, okay, papunta din sa may point O. Ito yung 45.9966. Then ito naman, itong distance na to, okay, from this point going there, so that is yung 25/3. So if we solve for the angle alpha, opposite over adjacent, that is tangent, we're looking for the angle, so shift tan, arctangent of opposite is 25/3 over 45.9966. So ang nakuha natin kanina angle is 10.2692. Okay, so we have a slight discrepancy. So nakuha natin is solving for angle alpha. Arctangent of opposite is 25/3 over 45.9966. So both in feet, so maka-cancel. 10.2690. So we have again slight discrepancy, but that's okay. Okay na yan, acceptable na yan. So this proves that, okay, so the hydrostatic force F will pass through point O. Okay, so that's it for this video. If you like this video, please consider to subscribe and share this to your classmates, review mates. Okay, so kung wala pa naman kayong ginagawa, so in preparation siguro sa next this coming school year. Okay, so again, thank you for watching this video. If nagustuhan nyo, please like, subscribe, and share. Okay, so see you again next video.